Every four-sided polygon is called a quadrilateral, and we see quadrilaterals every day in our daily life. And then there are some special kind of quadrilaterals like parallelograms, rectangles, squares, rhombus, kite, trapezium or trapezoid, and even chevrons. And if you want to learn about the properties of all these quadrilaterals and what they are, then you have come to the right place. Let's jump into the video straight away. Come on, let's go. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another video of ours. Exponent to Success is an initiative that helps to add an exponent to your learning curve. If you're new here or if you're landing on our channel pages for the first time today, I would strongly recommend that you subscribe to our channel right now so that you do not miss out on any future content from us. And do not forget to click on the bell notification also so that whenever any new content is uploaded, it comes right into your inbox. We are going to talk about quadrilaterals today, and like I said, we see quadrilaterals every day in our daily life. Now, what exactly is a quadrilateral? A quadrilateral is any four-sided figure. So like you see here, this is a vertex that we have, this is a vertex that we have, this is another vertex, and then we've got this. So this has got four sides or four corners. So any four-sided figure is called a quadrilateral. So this picture itself is a quadrilateral, and there are quadrilaterals everywhere we see, and we see them every day of our lives. So like I said, a quadrilateral is a four-sided polygon. But what exactly is a polygon? A polygon is any figure. So it could be a triangle like this, that's also a polygon. It could be a rectangle like this, that's also a polygon. It could be a pentagon like this, that's also a polygon. And it could be a hexagon like this, that also is a polygon. Or it could just be a star, that is a polygon, or an arrow, that's a polygon. Everything is a polygon. But what makes it a polygon? Well, a polygon simply states that it should have three or more sides. So the definition of a polygon is that it should have three or more sides, and they are named according to the number of sides they have incidentally. It should also consist of line segments only, and it should be a closed figure. So if we have any figure like this is not a polygon because this is an open figure. It is not closed. It has got an area left here which is not closed. So we cannot call this a polygon. And even we have got figures like this, 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 and this. This also is not a polygon because whenever it crosses its own path, it does not constitute a polygon. So this is not a polygon also because it is crossing its own path. One of the sides is crossing the other side, which is not allowed in a polygon. And then what about a figure like this, where we have got this, and this? Is this a polygon? Yes, this is a closed sided figure and this is a polygon, and it is also made up of line segments. Now what about something like this? Is this a polygon? This is not a polygon because even though it is closed, but it is not entirely made up of line segments. It has got only one line segment and the other is a curve. So a polygon cannot have a curve. So let us delete all those which are not polygons, and then we'll discuss only about polygons that are left with. Now, if we talk about polygons, like I said, there are different kinds of polygons, and a three-sided closed figure or a three-sided polygon is called a triangle. A four-sided figure is called a quadrilateral. A five-sided figure is called a pentagon. A six-sided figure is called a hexagon. This has got 1, 2, 3, 4 sides. This also is a quadrilateral. This has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides. So this is called a decagon, and this has got 1, 2, 3, 4, 5, 6, 7. Seven-sided figure is called a heptagon. Eight-sided figure is called an octagon. Nine-sided figure is called a nonagon. So like I said, any closed side four-sided figure is called a quadrilateral. So it could be something like this. This is a quadrilateral, or it could be something like this. This also is a quadrilateral. Now, what is the difference between these two quadrilaterals and why is it so? So, if we talk about this quadrilateral first, the one on the left, this is a quadrilateral because it's a four-sided figure, and this on the right is also a quadrilateral because this also is a four-sided figure. Now, the difference between these two is that the one on the left is called a convex polygon or a convex quadrilateral, while the one on the right is called a concave quadrilateral. And why is it called convex or concave is because the properties of a convex quadrilateral, first of all, you can come to know by seeing its angles or you can come to know by seeing its diagonals. So the properties of a convex quadrilateral is that all angles within the quadrilateral have to be less than 180 degrees. So if you see this angle here is less than 180, this is less than 180, this is less than 180, and this also is less than 180. If you talk about angles in this quadrilateral, this is less than 180, this is less than 180, this is less than 180, but this is more than 180. So we are always looking at the internal or angles of the quadrilateral and not the external ones, because then you may even say that this is not more than 180 degrees, then why is this called a concave quadrilateral? Now if you look at this, the blue one marked here, that's an external or angle of the quadrilateral. It lies outside the closed figure. We are looking at the internal angles which are inside the closed figure. So the internal angles, all of them have to be less than 180 degrees, then only they are called a convex quadrilateral, otherwise they are called concave. The second way you can identify concave quadrilaterals are by drawing the diagonal. So if you connect diagonals is that if you connect one vertex to the opposite vertex or a vertex which is not the adjoining vertex, for example, for this point here, this is an adjoining adjacent vertex. The vertex which lies next to this is called an adjacent vertex, but this vertex is not the adjacent. So any opposite vertex or non-adjacent vertex, if you join them together, that's called a diagonal. Can we form another diagonal here? Yes, we can draw another diagonal which is here and here. Now look at both the diagonals. Do they lie inside the quadrilateral? Is any part of the diagonal outside the quadrilateral? No, it is not. So therefore, whenever all the diagonals lie inside the quadrilateral, it's called a convex quadrilateral. And when they lie outside the quadrilateral, it's called a concave quadrilateral. Now, what do you mean by outside the quadrilateral? So if we look at this figure on the right hand side, so if we draw a diagonal, so we have got one diagonal like this. These two vertices, if I join, that makes a diagonal. And these two vertices, if I join, that makes a diagonal. Now, if you look at this, the one blue diagonal is inside the quadrilateral, while the other blue diagonal is outside the quadrilateral. So therefore, the one on the right is called a concave quadrilateral. Now, since in this video we are talking only about quadrilaterals, let us base our studies on special quadrilaterals. So there are some special quadrilaterals that we have, and they're called special because like a quadrilateral in a general term is any four-sided figure is called a quadrilateral, but those quadrilaterals which have a specific shape are called special quadrilaterals, and one such quadrilateral is a parallelogram. So this is what a parallelogram looks like. Now the properties of a parallelogram are that it has got two pairs of opposite sides which are equal and parallel. So let me mark them here. So we have got this side is parallel to this side and this side is parallel to this side. Now whenever there are arrows on a side, it means that the sides are parallel to each other. And if I can also mark that this side is equal to this side and this side is equal to this side. Now there are some other properties also in a quadrilateral, in a parallelogram, and they are that now these come from the properties of parallel lines. So if you know about parallel lines, when if we look at these two lines here, so let me give it a name also. Let me call this a quadrilateral A B C D. So if you look at these sides, when we have AB and CD, they are parallel lines, and if you look at AD here, that's a transversal to both AB and CD. Now if we look at these two angles, one angle here and one angle here, what are these angles called? So any internal angles which are on the same side of the transversal are called co-interior angles. And you know that in case of parallel lines, if you look at the co-interior angles, they always add up to 180 degrees, or we can also say that they are supplementary angles. Supplementary means they add up to 180 degrees. So the sum of these two angles is going to be 180. And if you look at C and D, well, AD is also parallel to BC and CD is a transversal. So angle C here and angle D here, they are also co-interior angles, and therefore they will also add up to 180 degrees. And same goes with the case with B. So A and B are going to be co-interior angles. They are going to be add up to 180 degrees. And B and C are also co-interior angles. They also will add up to 180 degrees. But what does that tell about A and C, or B and D for that matter? So if we looked at the first case, we saw that A plus D is equal to 180 degrees. And we saw that C plus D is also 180 degrees. Now, if both of them are equal to 180 degrees, then we can say that A plus D is equal to C plus D. And if we subtract D from both sides of the equation, we are left with A is equal to C. Now, if we look at A and C, they are opposite angles. So, opposite angles. Now, same way we can go and prove that B and D also are equal. So, if you look at the opposite angles, so opposite angles in a parallelogram are going to be equal, and adjacent angles in a parallelogram are going to be supplementary, or they are going to add up to 180 degrees. There are a couple of more properties about quadrilaterals, and that is when we look at the diagonals. So if we look at the diagonals here, we have got one diagonal here and we have got a diagonal here. We are going to prove it in the next video or in the coming videos that if we look at the diagonals of a parallelogram, if you look at this and this, they are going to be equal to each other. And if you are going to see this and this, they are going to be equal to each other. So we say that the diagonals bisect each other. Bisect means they divide each other into two equal parts. So DB is a diagonal which is dividing AC into two equal parts, and AC is a diagonal which is dividing the diagonal BD into two equal parts. But both the diagonals are not equal to each other. The angle of intersection can be anything. So these are the properties of a parallelogram. Now there are some special kinds of parallelograms also, and let us look at those parallelograms also before we go any further with any other shapes. So another special kind of parallelogram is called a rhombus, and a rhombus looks something like this. So what exactly is a rhombus? Well, if we look at the properties of a rhombus, first of all, we will notice that all its four sides are equal. So these four sides, they are equal, and the opposite sides are parallel to each other. So this side is parallel to this, and this side here is parallel to this. If we look at the diagonals of the rhombus, they are something like this. The diagonals are not equal to each other. You should remember that. Another property of diagonals is that they bisect each other. So this is going to be equal to this, and this is going to be equal to this. One more thing about these diagonals is that at the point of intersection where they intersect, they form a 90-degree angle. So this is a right angle, this is a right angle, this is a right angle, and this is a right angle. So they bisect each other at right angles. So we can say that all rhombuses are parallelograms because the opposite sides are equal and parallel. Other properties of the parallelogram also hold that the adjacent angles, they are co-interior angles, and therefore they will be supplementary to each other, and the opposite angles, they are going to be equal to each other. So those properties hold in a rhombus. So that's why it's a special kind of parallelogram, and special because here all its four sides are equal, not only the opposite pair of sides are equal. And since all four sides are equal, that's why it has been given a special name, which is a rhombus. Now there's a special kind of rhombus also. Instead, in case you didn't know that, there's a special kind of rhombus also, and that rhombus is something like this. Now this is a rhombus which all of you are very familiar with, because this is nothing but a square. And if you look at the properties of a square, you know what they are, that each angle inside the square is a 90-degree angle. So this is 90, this is 90, this is 90, and this is 90. What other properties of a square you know that this is all four sides of a square are equal. you know that the now what why is it a parallelogram? Because the opposite pair of sides are equal as well as they are parallel. So all four sides are equal. This is parallel to this, and this line is parallel to this, so that's why it's a parallelogram. What about the diagonals of a square? Well, if we look at the diagonal, so it has got two diagonals here, and this and this. And then if we look at the internal angles of the diagonal, uh, or what we notice about the diagonals is that both the diagonals are equal in size. So that's one thing which is different from a rhombus, because in a rhombus both the diagonals were not equal to each other. Here both diagonals are equal to each other and they bisect each other into equal parts, and since both diagonals are equal, therefore all four of these parts, they are going to be equal to each other. They also bisect each other at 90 degrees at right angles. So this is a right angle, this is a right angle, this is a right angle, and this is a right angle. Now a square resembles another kind of quadrilateral, also special kind of quadrilateral, which looks something like this, and this is called a rectangle. And the properties of rectangles are very similar. This is also a special kind of parallelogram only, where opposite sides are equal and parallel to each other. So this is parallel to this, and this line here is going to be parallel to this. This is, these two are equal and these two are equal. So they are just exactly like parallelograms. The only difference from a parallelogram is that here all angles are 90 degrees. Or you can say only one of the angles is 90 degrees. And then by logic, we can prove that since both the lines are parallel, this is a supplementary angle, co-interior angle. So this also has to be 90. And these two are also, these lines are parallel. So this is also a co-interior. This also has to be 90. And this also has to be 90. So all four angles in a rectangle, they are right angles. That is how it is different from a parallelogram. And you see, a square is also a special kind of rectangle because it has the same properties like a rectangle. The only thing is that here all four sides are equal to each other, and not just the opposite pair of sides are equal to each other. Well, what about the diagonals of the rectangle? So let's have a look at the diagonals also. We've got one diagonal here and one diagonal here. Now, if we talk about the diagonals, we can say that both diagonals are they're equal to each other. They bisect each other. So this is equal to this and this is equal to this. And since both diagonals are equal, they all four of these line segments, they are going to be equal to each other. There's one thing, however, different from a square, and that is if we look at the internal angle here or the internal angle here, that is not going to be 90 degrees. So the diagonals bisect each other, but they don't bisect each other at 90 degrees angle. Well, we have already looked at four kinds of parallelograms, and they are, let us recap. The first one that we learned about was called a parallelogram, and you remember the properties of a parallelogram. If you don't, you can just go back, rewind a little bit and see the video again. The properties of a parallelogram, we know a special kind of parallelogram, which is called a rhombus, and a special kind of rhombus, and a special kind of parallelogram as well, and a special kind of rectangle as well is called a square. And another special kind of parallelogram is called a rectangle. So we have already gone over four of these quadrilaterals. I'm also going to talk about trapeziums. Trapeziums are also called trapezoids, so they are synonymous to each other. I'm going to talk about kites, and I'm going to talk about chevrons. So let's come to trapezoids first. So if we look at a trapezoid is slightly different from a parallelogram in the sense. So if we look at this figure here, this is a trapezoid. And the property of a trapezoid is that in a parallelogram, both pairs of opposite sides, they are parallel to each other. But in a trapezoid or a trapezium, only one side is parallel to each other. So this line is parallel to this, but this line here is not parallel to this line. The sides are not equal, they can be any side. So if the sides are not equal, we can't talk about the angles also. But since both these lines are parallel lines, we can say that this angle here is a co-interior angle of this, and these two angles should be supplementary to each other, or they should add up to 180 degree. And so same goes with this case, that this angle here will add up to 180 degrees with this angle here. So both these angles are supplementary, both these angles are supplementary. We can't talk about the opposite angles because there's no correlation between them. So these adjacent angles here, they are not supplementary to each other, but these are supplementary and these are supplementary. Now, since there's no relationship of angles between them, there's no relationship of sides, equality of sides between them, we can't talk much about the diagonals also. This also, of course, has two different diagonals. So one is like this and one is like this, but we can't say anything about the diagonals. There can be different kind of trapezoids also. So don't get confused if you see a trapezoid like this. A kite is something which looks like this. And the properties of a kite, if we look at the properties here, uh, we have got two pairs of adjacent sides which are equal. So they are not, opposite sides are not equal to each other, but the adjacent sides are equal. So this is equal to this, and this side here is equal to this side here. So these are going to be equal. The one pair of opposite angles are going to be equal, which means this angle here is going to be equal about to this angle here. But we can't say the same about this angle on the top at the bottom. They are not going to be equal to each other. If we talk about the diagonals, only one diagonal will bisect the other diagonal, and the other diagonal will not be bisected. So if we look at this figure here, we can see that this diagonal which is going vertically, that bisects this diagonal. So this is going to be equal to this, but we can't say about the other diagonal that is not being bisected. And one more property of a kite is that if we look at the internal angle here, this and this, they are all going to be right angles. So they bisect, one of the diagonals bisects the other and forms a 90-degree angle there, or a right angle there. And the last figure that we have got, a special kind of quadrilateral, are called chevrons. And chevrons, like I told you, are polygons, but the only difference is that they are concave polygons. So this is a chevron. So any figure like this is a chevron. So it could be even a figure like this, for example. This is a chevron, so they don't have to be symmetrical to each other. So any four-sided figure, but concave in nature. So concave, like I earlier told you, concave means that one of the internal angles should be more than 180 degrees. So any kind of concave quadrilateral is called a chevron. And there are no properties of a chevron that we need to talk about. So these are the special types of quadrilaterals, and I hope that you have understood the properties of all and do remember them. And they are all very important properties. You should go back to the video, see it again if you want to, or a third time if the need be. They're all going to be very important properties, and they are going to be useful in the coming grades too. So in the end, I'm going to leave you with two figures. One is to think about. So if we look at this figure here, so we have got that all are quadrilaterals. Inside the quadrilaterals, we have got parallelograms, and there are special kind of parallelograms which are rhombuses and rectangles. And those figures which are both rectangles as well as rhombuses are squares. The figures which are totally different are trapezoids, chevrons, and even kites. This Venn diagram says it all, that all rectangles are parallelogram, but all parallelograms are not rectangles. All rhombuses are parallelograms, but all parallelograms are not rhombuses. All squares are rectangles, but all rectangles are not squares. All squares are rhombuses, but all rhombuses are not squares. All trapezoids or all parallelograms are quadrilaterals, but all quadrilaterals are not parallelograms. All quadrilaterals are not trapezoids. All chevrons are quadrilaterals, but all quadrilaterals are not chevrons. And the list goes on. So these are some special kinds of quadrilaterals that we learned about today. And in the end, I'm also going to leave you with a very interesting meme, which is here. It says that if killing two people at once is a collateral, then is killing four people at once a quadrilateral? So that brings us to an end of the video. I hope you enjoyed the video thoroughly and you learned something useful out of it. In case you did, I would like to hear all about it, so just head down to the comment section below and leave in your comments for me. In case you are facing any problems with any of your questions, or in case you want me to cover any specific topic, just mention that in the comment section too, and I'll surely get back to you with a video. I would surely recommend that you hit on the like button below and share the video link with your friends so that they also learn something useful out of it. And in case you haven't subscribed to our channel as yet, this is the right time to do so. You see a subscribe button right in the center of the screen. Just click on that and you'll be subscribed to our channel straight away. And do not forget to click on the bell notification also so that any future content is delivered right into your inbox. As a part of your continued learning, you can click on these videos shown on the left side here. Please like and share the video. Take care. God bless.